吕老师，我试一下声音，您能听到我的声音吗？
可以听到的。
好的，
听到。
好的。现在7点钟时间到了，但是我们这里只有20个人，我们先开始吗？
裴老师可以开始。
好的。Hello everyone. Good morning for friends from Russia, and good afternoon for friends from other countries. Good evening for friends from China, and welcome to the third session for the BRICS Future Challenge Camp. And this evening, our agenda is like this. For the first 30 minutes, we will have a question and answer session for the first 2 training sessions. If you have any questions related to the training program or the training lecture, or when you are using the software, feel free to ask. You can post your questions on the chat platform in Zoom. And Professor Tang Yandong will be here with us tonight. For the assignment of yesterday, you can send it to class teacher Lina individually via Zoom. Well, I'm seeing that we are having attendance coming in, so I probably will repeat the first 2 issues I mentioned. Number 1 is that we will receiving, or you can submit the assignment via Zoom individually to Miss Lina, the class teacher. You can see from the participants list. So it's named as class teacher, so you can submit to her your assignment. And the first 30 minutes will be the question and answer session. If you have any questions related to the training session or the lectures or the software, you can ask Professor Tang Yandong will answer the questions. And I will be the moderator for the questions and answer session before the lecture session and also after the lecture session. Professor Tang Yandong will provide us a lecture after the first 30 minutes of the Q&A session. And we will also have an after-class Q&A session after his lecture. Yeah, feel free to post your questions if you have any. If you would like to share any of your source on the training, feel free to do that as well. Yeah, I guess most of us are busy submitting your assignments. No problem. When you are finished submission your assignments, feel free to share your source, or if you have any questions, just post your questions. If not, that's fine. Miss Lina, could you please share the screen? 李娜老师，您可以把刚刚的这个屏幕共享一下吗？
是哪一个屏幕吗？
等会儿您要播放唐老师的这个
是唐老师自己放。
好的，好的，明白。
唐老师他自己播放。
好的 ，Professor 唐老师。
哎，我在。
Could you please share your screen？ 请您共享一下您的屏幕，可以吗？Yeah, while we are submitting our assignments, I'll ask Professor Tang to share his screen later because he will give us a lecture tonight and we can have a preview of the lecture.
Okay, can you hear me?
Yeah, I can. I can hear you clearly. 那好，您可以稍等一下，可以先放在这里，我再问一下他们有没有问题。李娜老师，您可以收到那个作业了吗？有没有什么问题？
目前还没有人交作业。
还没有人交作业是吧？
对，现在在线的人也不多。
OK。
而且基本上都是中国的选手们。
好的。So a kindly reminder that so all your assignment from yesterday you can submit individually to Miss Lina, the class teacher. Yeah, you can send her via Zoom. Yeah, feel free to unmute to ask or post your questions at the chat form if you have any questions. We're still having some competitors coming in, and probably other competitors are preparing or in the process of submitting their assignments. If you have any questions, please feel free to post your questions in the chatting platform in Zoom, or you can unmute anytime during the Q&A session if you have any. Okay, it looks like we're pretty good. Yeah, if not, I'm afraid I need to double check with each participants because we do not see any assignments coming in. I want to make sure everything goes well, smoothly while you are submitting the assignments. Okay. We see. Phantasma. Phantasma, can you hear me, competitor? Phantasma. Kindly reminder that please rename your profile name in Zoom to your full name dash and your country. For example, so my name is Linda Pei, so I rename it as Linda Pei China. So I know that when we are communicating or call our name, we know who we are and which team we are. If we have any questions, we can solve it immediately. Okay. Okay. Luma from Brazil, can you hear me clearly? Okay, probably they are still adjusting their equipment. Justin from South Africa, everything goes fine with you?
Everything is great, ma'am.
Okay, pretty good. So how are you doing with the camp? How do you feel?
It's okay so far. I'm still just adjusting for it, but it's not bad so far. Thank you.
Perfect. Yeah, feel free to contact us or
will.
post your questions as a chatting platform if you have any. Okay.
I will. Thank you so much, ma'am.
Okay, no problem. Okay, I would like to check with our class teacher, Miss Lee. Everything goes okay? 李娜老师，请问您做作业顺利吗？有没有遇到什么问题？
作业还是暂时没有人交。
没有人交 ，OK。
没有人提交。
哦，可能大家正在正在准备提交或者在提交的过程中。
我这边会收的。
Oh, okay. I see one question from Zoomer. I have a question. So Zoomer raised the question. According to the requirements of the assignment book, the file of the assignment book downloaded by the contestant needs to be renamed. Okay, whether the assignment book should be renamed according to the requirement of BIM 4.6. Okay. 好，刘老师、唐教授这位同学提出了一个问题，他说：“请问作业是不是要重命名？命名的格式是不是要按照我们的那个4.6表格4.6的？”就昨天
Yes, you must rename the drawing name and according to the BEP field.
Okay, that's BEP 4.6. Yes, Zoomer. So all the assignment should be renamed according to the requirements of the BEP 4.6. Okay, Zhang Luofei asked how to submit. So you can submit via Zoom. So you submit individually to Miss Li Na. 张罗飞，您可以把它在 Zoom 中私信提交给李娜老师。So all the assignment should be renamed according to the BEP 4.6. So there should be clear guidelines of how to rename your assignments. And when you are done with the rename, and you could submit it to Miss Lina, the class teacher of this training session via Zoom. So when you submit to her. Are we all good? Do we have any further questions? It looks like everything goes fine for now. Yeah, if you have any question, please feel free to post your question to the chatting platform in Zoom, or you can also unmute during the Q&A session. Oh, sure. So so have you got the BEP Zoomer? I think you all get the PDF document yesterday from Zoom. Dr. Kwong yesterday sent it to Zoom and also Telegram. I think you should all have that. And in BEP document, it has a specific guideline of how to rename it. I just want to double check, do you all have the BEP profile or the document? Zoomer, do you have that? Okay, if not, I'll send it now so you can all see it, just in case some of you may miss that. So this one is a document. Well, from the table of contents, you can search and find the rename specifications or the requirements. Then when you are renaming your assignments, you can follow the guideline on the BEP document. Okay, I think all of you can see the BEP document. It's really important, so you know how to follow the right format. Okay, thank you for your question. I'll double check with Ms. Lina, see whether there is any concerns or issues during the assignment submission process. 李娜老师，
哎，
您那边交作业有没有什么问题呀？有没有？
暂时还没有收到。如果说后面有什么问题，我给你说。
哦，好的。
目前他们还没有给我提交。
我们现在有31位同学，这个我们要不现在开始，等会儿继续交作业，还是再等10分钟？
要不就先开始吧，就是开始的同时，他们要慢慢的提交，再提交呗。
好的，可以。如果等会儿中间有问题，我们也可以，我们可以在后面，因为我们前面开始的话，后面也可以放在 Q&A session。OK。Okay. Dear friends, since we have no question at the moment, at this moment, I think we cannot wait to listen and learn with Professor Tang about today's training. Well, since we begin our training 10 minutes earlier today, and we'll leave the 10 minutes for question and answers after his lecture. So we'll have 40 minutes Q&A after his lecture. Well, if you have any questions, please feel free to post as a training platform in Zoom. Okay, thank you. So Professor Tang, could you please share your screen? 汤老师，您可以
OK，
共享
OK
您的屏幕。我们可以先开始。
Okay, everyone. My name is Tang Yandong, the coach of 2022 BRICS competition. I will give a lecture about Mode 1. Okay, let's start.
Hello everyone. Before using Plan Bar software to model, let's watch an animation to understand the construction process and the composition of prefabricated buildings. The progress of prefabricated buildings is a powerful starting point for green and low carbon circular development. Energy saving and emission reduction in the field of urban and rural construction compared with traditional methods. Research data show that prefabricated concrete construction projects can reduce waste emissions by 70% and water consumption by 25%. In fabricated concrete structures, typical prefabricated structural elements include precast concrete shear wall, precast concrete column, precast concrete beams, bottom plate of truss reinforced concrete composite slab, precast concrete stairs, precast concrete balcony slab, precast concrete air conditioning panel, and so on. Where precast concrete shear wall and precast concrete column belong to precast vertical members, which are arranged vertically. Precast concrete beams, bottom plate of truss reinforced concrete composite slab, precast concrete stairs, precast concrete balcony slab, precast concrete air conditioning panel are arranged horizontally belonging to precast horizontal members. Then, I'll give you 5 minutes. You need to browse the drawing of the prefabricated parts. Make sure you have a general understanding of precast concrete architectural drawings. After watching the animation, I believe all of you already have a simple understanding of prefabricated components. Then we will start to study the components of prefabricated wall. The prefabricated wall is a kind of concrete load-bearing member prefabricated in the factory. As a construction site, both sides of the wall lap on glue joints by reserving overhanging steel bars. The bottom of wall is connected with reserved steel bars of the lower wall through sleeve grout or glue joint method. Precast sandwich external wall is a kind of precast concrete outer wall with an insulating layer in the middle, consisting 3 layers. The inner plate is the middle insulation layer of prefabricated, declassified wallboard. The outer plate is a reinforced concrete protective layer. The inner and outer plates are connected to the concrete slabs and steel trusses on both sides of the composite shear wall by connectors. Manufactured at the factory as a cavity containing component. After installation on site, precast and cast-in-place concrete, co-stressed reinforced concrete walls formed by pouring concrete in the cavity. Prefabricated external wall panels are installed on the main structure, and non-load-bearing precast concrete external wall panels for maintenance and decoration are referred to as external wall. As a vertical member, the prefabricated external wall formwork (PCF) board is composed of the external liquid concrete layer and the thermal insulation layer through the thermal insulation connector. Horizontal extend steel bars are used for horizontal wall connection. The overhang shape has closed type such as U-shape, semicircular open type such as straight line, curved groove type, and vertical Austrian steel bars, which are used for the connection of upper and lower wall. The Austrian form is linear, generally in a plum-like arrangement. Then I'll give you all 5 minutes. You need to look through the information about precast wall panel in drawings and find out what thickness, height, protruding bar length, and overhang form.
While we are having the 5 minutes break, I would like to kindly remind you that you can all submit the assignments to Miss Lina, the class teacher, the training camp. And the assignment should be renamed according to the requirements in the BEP documents. The document is available in Zoom Zoom chat, you can just download, and it was sent yesterday, and I sent it again today. Should you have any questions, feel free to post your questions on the platform. Thank you.
Let's start to learn the types of embedded parts in prefabricated shear walls. They include hanging point embedded parts, temporary support embedded parts, formwork fixed embedded parts, sleeve grout and outlet hole embedded parts, reserved junction boxes and wiring grooves, hanging point embedded parts. Hanging point embedded parts include two types, which are threaded casing pre-embedded and hanging ring embedded parts. Threaded casing embedded parts mainly include 3D casing and universal lifting ring. During construction, connect the 3D casing to the universal lifting ring and then use a sling to hoist it. Hanging ring embedded parts mainly include lifting rings and hooks. Formwork, fixed embedded parts. It is to facilitate the formwork fixation of post-pouring joints. Holes are reserved at corresponding positions on the wallboard. During construction, the pull rods are inserted into the reserved holes, and the formwork can be fixed by tightening the bolts. The reserved holes for template fixing can be formed by pre-embedding plastic tubes or chemical metal rods. Temporary support, embedded parts, not less than 2 or 4 support points, and commonly use the 3D sleeves. Grout sleeve embedded parts. The grouting sleeve is manufactured by casting process or machining process, which is used to rebar sleeve grouting. The connecting grouting pot is a material pot for filling the grouting material, and the grout outlet is suitable for ventilating when filling the grouting material and overflowing the excess grouting material after filling. According to pressure grouting principle of the sleeve, the outlet hole is on top and the grout hole is on the bottom. Now, I'll give all of you 5 minutes. Looking through the drawing, you need to find out the specification of the embedded parts, the position and the quantity in the wall, and some other information. Next, let's take a look at the structure of the composite slab. Structure composition of bottom plate of the truss steel composite slab. Protruding bar at the plate end is anchored into support, forming a reliable connection. The reserved form is linear. The extended steels on the slab side overlap with the extended steels on the adjacent slab side, forming an integral joint between the plates. The reserved types include linear with 135-degree hook, with 90-degree hook, and bent into the steel truss, which can increase the rigidity of prefabricated panels during production, transportation, and hoisting, and the shear resistance of prefabricated panels and post-cast laminates. Pre-embedded wire boxes can be divided into PVC wire boxes and metal wire boxes according to their materials. As for the reserved holes, when there are vertical pipes passing through the floor, holes should be reserved on the prefabricated plate. Rough surface. In order to ensure the close combination of the prefabricated base plate and the post-cast concrete layer, rough surface should be set on the upper and side of the base plate. Normally, the concave, convex depth of the rough surface should not be less than 4 mm, and the area should not be less than 80% of the joint surface. Component identification includes component information identification, lifting point identification, and installation direction identification. Then I'll also give all of you 5 minutes. You need to find out the thickness, profile, outreach, length of steel bars, and the specifications of embedded parts of the composite slab within the specified time. After understanding the assembly building, let's start to learn more about our PlanBar software together. Since PlanBar is a very powerful software, many people may feel at a loss when first coming into contact with it. Therefore, I made a simple sorting of this software's functions. When you need to build 2D models, such as curves and straight lines, we can find it in the basic tools. When you need to build 3D entities, then we can find it in the additional tools. When you need to build line, intersection components, or building construction, then we can find it in architectural tools. When we want to build the modeling or reinforcement, we can find it in the engineering tools. When we want to create a wheel, we can find it in the wheel type. When we want to build a prefabricated building, we can find it corresponding functions in the prefabricated components. Finally, when we need to do animation and rendering, we can find the relevant options in energy tools. You can quickly find the functions you need to use when you operate. Firstly, know how to create embedded components. Secondly, know how to create precast parts without reinforcement. Thirdly, learn how to create prefabricated parts with reinforcement. According to this mind map, it can be seen that our content today has 3 main parts. Each part can be divided into 3 models: creation, modification, and layout. We know that to create a component is actually to give the corresponding properties to this object, and then to position this component in 3D space. Positioning is to provide the x, y, and z coordinate values of the component. The second is the modification. That is when we need to make changes to the model. We need to know how we can modify it. Thirdly, after our model is created, we need to arrange the model into 3D space, no matter it is a precast or assembled component. We will explain and demonstrate through these 3 steps today. For the first part, embedded parts, it can be divided into 2 parts. The first is the creation of the model. The second is the creation of the catalog. It is equivalent to create a model first and then give it a name. After the model and the name correspond one by one, our precast parts will be created successfully. The second part is how to create precast elements without reinforcement. We can also divide it into 2 parts. The first one is to create directly with our assembly components, which can be created with 3D entities or with parametric definitions. The second one is to use building components to make a transformation, then modify the assembly components. mainly by driving on the assembly components. The third one is the layout. When the assembly is defined, how to arrange it in 3D space. The third major part is the creation of precast elements with reinforcement, which is also divided into manual and automatic creation when creating new ones. The first manual creation, the first need to create a rebar wheel. The purpose of creating a rebar wheel is to define the location of our rebar in the three-dimensional space. Then the second step is to set the shape of our rebar. The third step is to set the rebar in space for placement. The second one is automatic creation of our rebar, including the creation of longitudinal and transverse rebar, and the creation of truss rebar. Now you are given 5 minutes to open the software and try to find the location of the relevant function buttons. Okay, everyone, we will officially start the creation of the embedded elements. Before creating the embedded elements, we have to create 7 new models of the embedded elements in the drawing field, including 6 2D models and 1 3D model. First, we have to create the model. If the model needs to be rotated, we have to create rotation axis, determine the angle of rotation, and then we can rotate our model. After the whole 2D and 3D model is created, we have to modify the properties of the model. The modifications include the color of the lines, the layers, and so on. Here we will formally define our precast parts in the software. Firstly, we need to open PB software, find the corresponding drawing file, and then double-click blank area of the wheel. The drawing field will pop up. Modify the drawing field you need to use as the main drawing field. Then double-click on our drawing file and start creating our 6 or 7 models in the drawing file. We will now start to create model of a cylinder as an example. First of all, select our cylinder in the 3D entity. Click it. Determine the location of its datum, the radius of the cylinder section, the radius, the height of the cylinder. This information is required to fill in accordance with the requirements of the drawing. For example, we fill in its height of 310 millimeter. Click on the placement is complete. At this time, if we can't find it in the production field, we double-click the middle button of the wheel. You can see the model. Our 3D model is created. The rest is to create this cylinder's top wheel, inferior wheel, front wheel, back wheel, left wheel, right wheel, a total of 6 2D models. We can use our basic inside the circle this command. We can first create its top and inferior wheel. The top and inferior wheel is just to define its radius, and then copy it. Because the cylinder's top and the inferior wheel are round, is the same, so we can directly use the copy command, and then you need to create the front, back, left, right, 4 wheels of the cylinder model. We can now, by looking at the rectangle, so we use the rectangle command. Enter its cross-sectional dimensions, click OK to complete the creation. Since the remaining models are all the same, it is possible to duplicate. You can use every copy. Click OK and finish copying. Thus, we have created the entire model of the embedded elements. Now, we want to modify the line type, color, and layer of the embedded parts. First, we click Modify Properties and then change the line color. Then modify the layer and set the layer of the then modify the layer and set the layer to the one required in the assignment. Click OK and then check on all of our models that have been created. You can see that our model line color has been modified. Since the already created model will disappear when defining the embedded elements, we first have to make a copy of the embedded elements model before defining it. Next, give you 5 minutes to do an exercise. Okay, after all precast parts are created, next we will do the definition of the precast parts catalog. First of all, the main operation of our embedded elements catalog consists of two parts. The first is to select to the catalog model under assembly components, and then need to enter the name of the embedded elements. Embedded parts save paths need to save according to the task requirements. The precast parts are divided into symbolic precast parts and linear precast parts, and this cylinder is defined now. It belongs to symbolic precast parts. Okay, next we'll start operating in the software. First, we'll select the precast parts tab in the toolbar and then click on the catalog. Then create a new embedded elements catalog. Then click OK after you want to change the name 3 times in 3 places. After confirming our embedded elements catalog is created, then we have to associate our embedded elements catalog with our embedded elements already defined model. Click the prefabricated slab or prefabricated wall, then click the embedded parts. Click the definition of prefabricated parts. Enter the name of the prefabricated parts. The name of the prefabricated parts preferably with the name of the prefabricated parts we just defined. And then select the symbol prefabricated parts on the left. Select the catalog we have defined. Then click OK. Now we have to define our model and our wheel one by one. First, we select 3D wheel. Click the cylinder, then click the animation wheel window. Modify wheel type to wireframe mode. Find the bottom center of the cylinder. You can turn off the navigation mode and then the left mouse button to select the midpoint. The mouse on the bottom of the cylinder, the computer will automatically capture. Then click the left mouse button, select our wheel as 3D wheel, and then click OK. Select the top wheel, inferior wheel, front, back, left, and right wheels in turn. The operation is the same as before. First select the wheel and then define our datum for this model. Thus, all 7 wheels of our embedded parts have been defined. At this point, we press ESC to exit and the embedded parts are created. Then, in the project folder, create a new 3D folder. Then, save it alone. Save the embedded parts we have created to our corresponding project folder, so we can find and call the new precast parts in this folder next time. Next, give you 5 minutes to do an exercise. After the embedded elements are created, we have to learn how to modify the embedded elements. Because sometimes we may find that the model or view of all embedded elements corresponds to the wrong relationship, or the reference point is wrongly selected. So, how can we modify it? Let's see how to operate in the actual process. First of all, choose to modify the embedded elements display parameters in the embedded elements, not the parameters of the embedded elements. And then double-click an embedded element which is wrong. Let me take a look at the wrong embedded elements. Let's see what errors it has. We can see that 3D view of the datum point is wrongly set. So let's first make a change to it. Then we click delete view. Select the view we want to delete and click OK. View. You can see that our 3D view has been deleted. Now, we redraw a cylinder and then let it establish a correspondence with the 3D view. Click OK. So that our model of the embedded elements is modified. We will call out again at this time to see what's the difference with earlier. We now retrieve all its views and can click on the component information to know the order in which the views are arranged. You can see that the 3D model is on the far right, and its datum point is already at the center of the cylinder. Then it is how to arrange the embedded elements that have been defined. We first need to correspond to the project embedded elements folder. Find we have created a good embedded elements, and then to select it. Determine the position of the components in space requires 3 coordinates x, y, z. Where a plan wheel can only determine 2 coordinates, so we need at least 2 wheels. You will want to accurately lay out the precast components. Generally, the x and y coordinates are determined in the top view, and the z coordinates are determined in the elevation view. Okay, give you 5 minutes to practice the modification of the embedded elements. Next, I will give you an explanation about the creation of linear embedded parts. First, we set up the catalog. We click on the catalog and click on the embedded catalog. Create a new embedded parts directory. Modify the name of the linear embedded parts. Change its embedded type of linear. And then finish the setting. Apply save. Exit. We click on the embedded parts command. Define the embedded. Before that, we need to set a cross-section. About the cross-section of the linear embedded. So, we first create the section using the 2D tool. First, we create a circular section. We click on the circle and draw a circle with a diameter of 40. After the drawing is done, we are in the library. In the project, this project path or another path, we create a new 2D element field, civil 2D symbol, which is a circle section, into the new 2D elements field. We click on Insert Element, Insert Symbol, and select Circle section. Determine a base point. Save it as a general symbol. Change its name. Change its name to Circular section. Then OK. After completing the pre-work, we can start creating linear embedded elements. We define the embedded element by clicking on it in prefabricated elements. First, we can change the name of its element. It is called circular embedded element. Among the types of fixture, we choose linear. In directory, we select the directory we just created. We click OK. In the pop-up dialog box, we select Contour under the symbol content. There is a field icon. We click on it. In the field, we find the field where we saved the 2D section. Then apply the section and click Apply to confirm. The dimensions of the section will be displayed next to it. When the application is complete, below the symbols in the intersection with the prefabricated elements, we can choose either positive growth or negative shortening, depending on our needs. We choose positive growth here. When we are done, we click OK. In the pop-up dialog box, we select all elements on the default layer. Select Save Path. We can save the linear prefabricated elements to the prefabricated items. Create the linear prefabricated elements in the project, and save the linear prefabricated elements we created. Click Save. Finally, enter. The linear embedded parts are created created successfully. Next, we will apply the linear embedded parts. Practically, let's click on the embedded. Find the linear embedded we just saved in the project. Then select the embedded part. Then specify a starting point. Enter its end point or its trajectory. Once you have finished entering it, you can press ESC to exit and finish creating the embedded part. The embedded part is now created successfully. Now, you will be given 5 minutes to work on the creation of the linear embedded parts of the Next, we start the creation of assembly without reinforcement. It is worth noting that when defining the assembly without reinforcement, we need to pay attention to the name of the assembly, especially the cross-sectional dimensions of the assembly. We must pay attention to the elevation of the new assembly, because the elevation of our plan bar software is based on the elevation we used when creating the drawing file. The elevation of our plan bar software is based on the elevation when we create the drawing file to create the assembly as a reference elevation. And then we need to make an adjustment to it based on the reference elevation. Next, we will explore the 3 members of the beam, wall, and slab without reinforcement, and modify and create these 3 members. Let's proceed with the software. First, let's open the set of drawing files created by double-clicking on the empty space in the wheel. Find the corresponding drawing file created, and then double-click on the corresponding drawing file. In this drawing file, let's create a prefabricated construction without reinforcement. First, click the Prefabricated Elements tab. Then, click Prefabricated Elements, and then click Auxiliary Prefabricated Elements. Then, we will create a new prefabricated beam. Select the prefabricated beam, and at this point, we need to make a choice. Choose the way the beam is created. There are 3 creation methods by default in this software. The first one is the parametric. The second one is 3D solid and building comment creation. And the third one is created by Python part. We most commonly use the first 2. So I will only introduce the first 2 ways to create prefabricated comments. So first of all, the first way to create prefabricated beams. The first step, we need to define the width and height of the beam. When defining the height, we can click the ellipsis on the right side of the height option, and then at this time we can view the elevation above the prefabricated beam. Height association has many kinds of display. In general, in the up precast beam, you can choose to use the default top level as the upper datum, and then adjust the distance of the precast beam relative to the top elevation. And in this top datum elevation, enter a positive value for the top surface of the prefaced beam to offset that value relative to the elevation, and enter a negative value for the top surface to the precast beam to offset that value relative to the elevation downward. In down, we use fixed member height and enter the section height of the precast beam directly, so that the section size of the precast beam is defined. Then draw the precast beam. First, determine the starting point of the precast beam. Then determine the length of the precast beam by typing or other means. Complete the precast beam creation. Okay, give you 5 minutes to practice. The next step, we will complete the creation of prefabricated walls without reinforcement, just like the operation of creating prefabricated beams just now. It is worth noting that we use parameters to create prefabricated beams when completing them. However, when creating prefabricated walls below, we will use building components to create them. So, let's explore the operation of creating prefabricated walls use building components. First of all, let's select the prefab element among the prefab elements, where the auxiliary prefab element is selected to be built as a wall. And at this point, we can see under General the input options, where there is an option for an architectural element. We check 3D solid and building element. After we check it, we need to have a building element as a carrier for prefabricated wall. Then, before this, we first need to create a new building wall. In the building type, click the wall, and then create a building wall according to the actual needs. After the completion of the creation of the building wall, double-click the building wall we have created. In the pop-up properties, interface can be modified according to the needs of the wall height, thickness, line type, fill color, and animation material. Finally, click OK to complete the creation of the building wall. Again, return to the auxiliary prefabricated elements in the wall, and then select 3D entity and building components. At this point, we need to, in the pop-up Input Options window, close the Convert and Match. After finishing, click on the building wall we need to convert. Complete the prefabricated conversion. At this time, we need to pay attention to the properties. Menu pop-up in the properties menu bar. Location can modify the cursor and the wall datum. Then we can click the left mouse button in any location to place the prefabricated wall. So we can see that the prefabricated wall has been created successfully. Now you are given 5 minutes to try out a new prefabricated wall using the building component transformation. Next, we will use the last way to create the prefabricated plate. That is to use the 3D entity to create the prefabricated plate components. Before creating the prefabricated plate, we need to create a carrier to complete the prefabricated transformation of the carrier. First, need to create the 3D entity about the plate. Next, we will explore the creation of 3D entities. In the 3D add-on tool, we will first create a 3D entity corresponding to the prefabricated panels. Sometimes, we need to make a hole in the prefabricated plate, and there are several ways to do this. But here, I will use the hole in the 3D entity. Of course, we still need to create a prefabricated 3D entity first, and then create another 3D entity at a suitable location. That is the 3D entity of the hole. And then we need to open the 3D entity of the prefabricated plate after the completion of the creation. To do the opening process, we need to use the additional tools. In the to do so, we need to use the reduce set and delete entity command. Next, we are going to create a prefabricated panel with holes. First, we will create our 3D entity in the add-on tool. Enter the dimensions of our 3D entity, then set its thickness, which is the thickness of the plate, and click OK, so that our 3D entity is created successfully. Next, we need to make a hole for this 3D entity. Then, we need to use a reduce set and delete entity command. Before this, reduce set and delete entity command can be used, we need to create another 3D entity that intersects with the board. That is, let's create it together. First, create a hole of the required size. Confirm that its thickness is the same as the thickness of the plate. Click OK. Then, we have created two 3D entities successfully. We can switch to the 3D view. Go to Observe the 3D entity we created. We first select the upper left corner of the board, that 3D entity hole. You can see it, and our original border 3D entity is overlapping and did not subtract the whole 3D entity. At this point, we use the reduce set and delete entity command. First, we need to single select the need to open the hole in the board, and then click to select the whole 3D entity. And finally, the right mouse button to determine. In our three-dimensional view, you can see the use of the reduce set and delete entity command to create the 3D entity. At this time, with the hole in the prefabricated plate 3D entity has been successfully created. Next, we need to convert the 3D solid with a hole into a fabricated plate. We go back to the auxiliary pre-elements in the prefabricated comments. Select the plate, then select 3D solid and building construction, and then in the import options window that pops up, activate convert and match, after which click to select the component we need to prefabricate it to convert. Finally, we can see that the prefabricated board has been created successfully. We can mouse over the edge of our board. We can see that the properties of the board has been changed from the original 3D entity to the auxiliary prefabricated elements, and the prefabricated board has been named. In addition to the naming information, there is also information on the dimensions of the board and the weight of the board. You will be given 5 minutes to do the exercise. We all practice well. So next, we go together to explore. In addition to the 3D entity can open the hall, we have another way to create the hall settings. That is prefabricated unit modeling. First, we need to create the prefabricated wall successfully. Then, we need to determine the size of our opening on the pre-created wall. And finally, determine the height of our hall. Now, let's try to do the prefabricated unit modeling of the openings in the software. First, we have to create a successful wall. We have to do it in more than one view. If we want to use prefabricated unit modeling, the view here is not the window view. We click and select the view, section, detail, comment in the reinforcement view, and then create a view of this wall. We use the create view command to create at least two views. One view on modifying the XY axis coordinates and another view on modifying the Z-axis coordinates. Click on the Create View command. Select the build we need to create a view for, and then create the main view and the top view respectively. By creating the top view and the main view, we can determine the three coordinate value of our hall. Then we go back to the prefabricated units modeling. In the prefabricated components of the assembly building, click Prefabricated Units Modeling. We need to define the properties of our prefabricated units modeling first. Next, we have to select negative or shorten in the content of intersect with the prefabricated components. Then, click OK and draw the shape of our prefabricated units modeling in our view. Then, click OK and then draw the shape of our prefabricated unit model in our view. First, create the cross-sectional dimensions of my hall in the main top view, and then determine its z-coordinate thickness in the top view. Then press ESC to exit. You can see in our 3D view that using prefabricated unit modeling, you can make holes in the wall, but of course, you can also make the holes in other components, such as slabs, at the same time as you make holes in the wall. You will be given 5 minutes to do an exercise.
So while we are waiting during the break, I would like to clarify that the assignment for yesterday's session was from the sample textbook. For the document we had in Zoom yesterday, and also I sent it in Zoom today. So the assignment was from page 4 to page 6. So there is a question 2, sub-question 1, 2, 3. I also took a screenshot and then send it to the Zoom chat platform. You can also check. Yeah, if you have any questions regarding the assignment, feel free to ask. So on page 4, the second subheading is structural modeling and structural modeling. So there are 3 sub-questions assigned as the assignment yesterday. So first one was name the number 2 file as grades. Number 2, name the number 3 file as cost in place structural guide. Number 3 was on page 6. Name the number 51 file as standard cost in place floor structural model. So those 3 exercise was the assignment for yesterday's session. In case you are still feel confusing. So when you are done with the assignment for yesterday, you can send it to Miss Lina, the class teacher, via Zoom, and you can use private chat. Thank you.
So remember, is it possible to show us how you name the files? Just give us one example.
Oh, sure. I'll talk to Professor Tang after his lecture, and we'll give you a hands-on example to show how to rename, okay? Is that okay?
Okay, thank you, ma'am.
Yeah, probably we need to have a screen sharing so we can show you the exact page on it or an example. Is that okay?
Yes, ma'am, much appreciated. Thank you.
Okay, you are very welcome.
Next, we will give you information about the way to lay out prefabricated panels or plates. First of all, we don't need to draw the slabs one after another by entering their section dimensions. We can draw it by combining the functions of plan bar software. In this training, we will use the prefabricated plate command in combination with filters to quickly lay out the prefabricated plates. The first filter we use is called match filter condition. Our example here is a layer filter of the match filter condition. Of course, it is not limited to this filter. You need to use specific filters according to your needs and the actual situation. The general process is that we first select the element conditions that we need to match with the filter. After selecting the element conditions, click to identify the layer we need to filter. After the final match is complete, select all and the system system will automatically help us filter all the elements that meet the element criteria. Next, we will demonstrate by doing it. First, we import the drawing. After importing the drawing, find the match filter condition in the bottom right corner and click on match filter condition. Select the layer element. Click OK. At this point, our cursor changes. It turns into a kind of straw icon. And then we select our plate outline element. Click on the plate outline. After the layer element is identified, box it. Frame all builds. At this point, we will see that our board layer is selected and we can do the debugging at this point. Copy the outline of the board. We then get the outline of the board, and we can create directly on the outline of the board. This has greatly accelerated our efficiency in laying out the board. And at this point, we can then use a prefabricated board command to create the board on the borderline. This is how we can improve our modeling efficiency by combining different functions in PlanBar.
Okay, Professor Tang, could you please show them the example of how to rename the file on BEP? 唐老师您好。
我能听到，
刚才有学生提问，这个作业的格式重命名，按照 BEP 的这个格式命名，他们不是太清楚。您可以通过屏幕共享的形式，打开那个 BEP 的文档，给他们演示一下怎么样命名，可以吗？您有那个文档吗？
我要准备一下，因为这个 BEP 是昨天讲的。我准备一下吧。还有没有其他问题？
好的，他们暂时没有其他问题，我再告诉他们一下。Okay, Professor Tang will prepare and then we'll answer our question of how to rename the BEP the file according to BEP specifications. You can also refer to the instruction guide on the file we sent out yesterday.
别说这老师的音乐可以啊，听起来。
开玩笑的。
If you have any further questions, feel free to post it to the chat form, or you can always unmute because the following 30 minutes will be Q&A session. So we have a question here from the Russian team. Is it possible to use software other than PlanBar for BIM modeling? Which software is allowed to be used? 唐老师您好，这个学生，我们的俄罗斯团队提出了一个问题，他们是说我们的比赛在做 BIM 建模的时候，能不能用除了 PlanBar 之外的其他软件？有哪些软件是可以使用的
暂时是不能用其他软件的，就只能用 Plan Bar 软件，在它那个大文件里面有要求的。
Okay, for this future challenge competition, we now only allow Plan Bar for the BIM modeling. And this has been specified in the instruction guide. 他们说能不能用其他的这个电脑？我们的这个电脑的这个硬件的要求，是不是这个说明上也有啊？我想他下面一个问题是，是不是很用这个2个显示器是不是必须的？也就是是不是很重要？是不是很重要
？2个显示器肯定会对它的这个建模的速度有很大的提升，最好是用2个显示器。
So Professor Tang's response for the second question was, so 2 displays will have faster speed for their modeling. So the recommendation is to have 2 displays. 他另外一个问题，他提问了在那个infrastructure sheet， 在我们前面的那个表单里面有一个 BIM competition，BIM 的这个竞赛指的是什么？然后他是说用这个软件中可不可以用他们的俄罗斯的这个俄语，用他们的语言，是不是必须用这个用我们指定的这个英文的软件环境？
这个问题，
这
个问题，可能要咨询一下，其他人，就是具体国外的选手在什么样的环境下比赛，这个
软件的语言环境，
我也不太清楚，应该是都要在英文环境吧。
Okay. So for the question about language requirement in the software during work, we will ask the organizing committee, and they will get the accurate response to you pretty soon.
裴老师，所有的选手，不管是中国的还是国外的，我们竞赛的环境全都是英文的。就是软件的环境都是英文的。
Okay, so we have Professor Liu responded to that. So it's clarified that so all the software should be used in English. So do we have any other questions? Yeah, feel free to post your questions if you have any, and you can also unmute and ask as well. Yeah, in case you forgot it just now because we were busy listening to the lecture, I would like to clarify again for the assignment from yesterday. So the assignment from yesterday was extracted from the sample test paper document. So it's available in the Zoom chatting history. You can also download it. And the assignment was taken from page 4 through page 6. So there is question 2. And the assignment was question 2.1, 2.2, and 2.3, sorry. 2.1 through 2.4. You can always submit your assignments to Miss Lina, the class teacher, via Zoom private chat.
备份吧，创建什么项目备份吧？
这个
等一下吧。不是的，哎，我靠，发英文版我不知道。这个上面
啊，对，白发。
然后修改名，选定一个目录，然后修改名称。修改名称就行。
对。
这个 CC 杠CC 之类的。这个昨天没讲。
下划线怎么说？
唐老师，一会儿您可以用中文，或者是您把格式展示出来就行，我大概给他们解释一下。
好的，我这儿准备好了。
Okay, so Professor Tang will show us how to rename the document according to the BEP file requirement. You can also refer to the BEP file document and do a hands-on practice with Professor Tang.
能看到我的屏幕吗？
可以看得到。
嗯。
可以稍微大一点。OK， 上面那个表格是不是格式的要求啊？
上面这表格是关于楼层那个编号的。
OK，
他们应该是想知道是这个。
好的。
就是在这个文件导出的时候，它在这个表格啊这些或者三维模型啊，它有一个导出的一个命名要求。然后这个命名要求呢，它主要是分为这8个级。首先第一个级呢就是 project， 然后它举例命名可以命名为 QCA， 然后下划线就是在下面这个表格里面。就比如说这里面就是第一级 project code 就是 QCA， 然后originator 就是我们可以选根据它的要求应该是 CCC， 就是 general contractor and function breakdown because we don't have volume, so we can choose ZZ， 我们就可以选择这个 ZZ。然后下一个呢就是spatial breakdown， 然后因为我们也没有这个标高，没有对标高进行具体的这个分隔，所以我们也都是 ZZ。它这地方就是multiple levels。然后下一个呢就是这个 form 就是根据我们这个具体的这个文件的形式，有这么多文件的形式，比如说我们的3D 模型，那我们就要选择 M3， 就这个 Native 3D Model Fill。然后下一个就是 Desimplify， 这个就可以根据我们到底是 Structure 还是 Architecture， 是结构模型还是建筑模型。我们比如说我们是建筑模型，就是 A， 然后后面就是它的 number， 就是它的编号001、002、003。
好的。好的，您可以推到上面那一页吗？我给他们解释一下。Okay, well we are done with the modeling, so we need to rename the file. So the file we have 8 levels. For example, level 1 is project. For the project, you may name it as QCA. And the second level, originator. Between each level of the name you may have a dash. And the third level is volume. And then the fourth level, type, row, number, and description. And each item is explained in the following table. And we can see some examples. 唐老师，您可以翻到下面一页。好，这一页可以稍微大一点点。For example, so the level 1 name should be labeled as QCA. So that's a code QCA for level 1. For level 2 originator, so typically we have CCC for general contractor. Well, for the third level, we do not have specific specification. So we have ZZ. We name it as ZZ. It means multiple volumes or for all. So you only need to use ZZ for the third one. For the fourth one, it's the same with the third one. We do not have any spatial breakdown for this project. So you may also use ZZ for spatial breakdown and also the fourth level, ZZ. Well, for the fifth one, it's a form. You may name it as a document. For example, if it's a 3-dimensional or 3D model, you name it as M3. If it's a 2D drawing, 2-dimensional drawing, you name it as DG. 唐老师，这个对吗？这个是根据具体的情况，对吧？
对的，对的。
好的 ，OK， thank you. For the fifth level, it's a form depending on your model. If it's a drawing or model, for example, it's 3D model or 3-dimensional, you name it as M3. If it's a 2D model file, you name it as M2. And you can also refer to other examples from the table. And this document is also available to you in the Zoom history yesterday. If you do not have access to this one, you can post it in the Zoom platform and I'll send it again. And then the next level is for the discipline. So this is quite straightforward. For example, if your model is an architectural model, you use the initial as A for the code. If it's a building control model, you name it as B. If it's a civil engineering model, you name it as C. And others you can see from the examples as well. So the last level is a number. For example, the first one should be 0001, and the second one should be 0002. Okay, are we good? Do you have any further questions regarding to the naming format?
Yes. Thank you, ma'am.
Okay, no problem. So we all have this document, right? The BEP document. It was available yesterday. If you do not have one, please do not hesitate to post in the platform, and then I will send it to Zoom platform. Yeah, if you have any further questions, feel free to unmute and talk it out loud, or you can post it on the chat form. Okay, we have one more message here. Okay, thank you. Looks like we are doing good. Well, congratulations, everyone. We have done with the third day's training. Okay, I'll check with the classroom teachers, see if we have any questions or issues raised with our assignments. 李娜老师您好，作业那边有没有问题呀？
作业目前收到了2个学员的作业，其他的都还没有交。
也没有什么问题是吧？
哎，没有什么问题。
Okay, thank you for the 2 students who have already submitted your assignments. I'm sure other assignments are on the way. 唐老师您好，今天的作业是什么呀？
今天的作业就是我们还是 Model 1的这个结构部分，就是在这里。从这里开始的 structure，
昨天我们做了1、2、3是昨天的作业，到第6页上面的第3小题，就是他们今天要交的。So these were the assignments for yesterday, 1, 2, and 3.
然后下面的这个从4，一直到7，就是我们今天的作业。
今天的作业 ，OK. So our assignments for today, for October 19th, the assignment today is from question 4 to 7. It's also extracted from the sample test document. So I'll also post it on the chat platform. So the assignment should be due tomorrow before the end of tomorrow's session. So for the following days, all the assignments should be due before the end of the next day's session. If you have any questions, you are always welcome to contact us via email or in the Telegram chat, or you can also post on the chat form of Zoom before class during the Q&A session. Okay, today's assignments. Page 6. So this one is page 6. 唐老师，这个还是第6页对吗？是的。Sample test document. Question 2.4 through 7. Looks like we are all good. If you have any further questions, feel free to unmute and ask. We are here to discuss or to share. Okay, Corbina, You don't have one question, or you do have the document, okay. So for the following 15 minutes, we'll just wait for competitors to submit yesterday's assignment. Any questions, you can post it to the platform. The document, please. Sure. So the BEP document or the, so Kobina, are you talking about the BEP document? Okay, I'll send all the document we need today for the assignment. Again, okay. Hold on a second. Okay, there you go. Okay, no problem. For tomorrow's session, Professor Tang will also be with us. And tomorrow's session will be about column creation and reinforcement setting. Okay, I think we are all good. No, the class teacher Lina, she will be here with us, waiting for students to submit their assignments for yesterday. Well, if you have already submitted your assignments for yesterday, you are free to go. And our session will be ended very soon. If you have any question, feel free to ask. If not, that's fine. If you think of any questions later, you can also submit to the group chat, or you can share during tomorrow's Q&A session.
就是明天，裴老师，明天还有一个互动环节的嘛，就让他们说一下，因为今天不是给他们看了一下这个装备式结构嘛，要不要把那个互动环节放到明天的问答环节里？就是那个讲一下他们家乡的这些，他们国家的这个。
Okay, Professor Tang proposed that for tomorrow's Q&A session, we would like to hear participants from different countries and regions to share about the development of prefabrication slabs or prefabrication buildings or architecture in your country or in your region. Yeah, we may be able to share during the Q&A session. We can have a group discussion during that time. So the question is, talking about the development of prefabricated architecture in your country or your region. You can also share about your thoughts on prefabricated structure. Well, I can also type in the question on the chatting form. So I just posted on the chatting platform. So the discussion question for tomorrow is, please talk about the development of prefabricated architecture in your country or region. Any thoughts and ideas about prefabricated tactic or prefabricated structure or technology are welcome to share.唐老师，我刚刚把您说的问题输入在这个聊天区了，您看还有什么要补充的吗？
就是这个问题，可以了。
好的，好的。
唐老师、裴老师，如果大家没有什么问题，我们今天也可以结束了。
好的，我想问那个李大老师，不知道作业有没有收完？如果我们结束的话，他们是不是交不了作业？
我这边应该他们要交的应该就已经交了，因为这个
已经交好了。好的，那我们就可以结束了，好吗？
好的，
好的。
Okay. Okay, thank you everyone for today's session, and wish you all have a wonderful day. Wish you all have a great night for our Chinese participants. Thank you very much and see you tomorrow. If you have any further questions, please feel free to contact us via email or Telegram chat. Thank you very much.